Hello, everybody, and welcome to our engineers interviews. My name is Josh, and I work at Primary Engineer. Before we start the interview, I'd want to say thank you very much for joining this year's competition. This year's our 10th anniversary, so we thank you all so much for celebrating it with us. We can't wait to see all your amazing designs and creative ideas. You will get some inspiration today from our special guest speaker, who is Alex. So you can answer the question, if you were an engineer, what would you do? As part of these interviews, we're going to be speaking with engineers who work on lots of different projects all around the world and showing how wonderful and interesting and exciting things that happen within the engineering industry. Although these interviews are hosted live, you can also catch them on YouTube. We post them every Friday, so you can watch them at a later date and then begin your entries. Our special guest speaker today will start with a 10-minute presentation all about how 3D printing is shaping the world, and then you can open up to questions from the audience. Now let's hand over to our special guest, Dr. Alex, who's going to talk about the world of 3D printing.
Okay, thank you very much. Great. So good afternoon, everyone. Thank you so much for spending your valuable afternoon with me and Josh. My name is Chu Lun Alex Leung. I'm a materials engineer and also a lecturer on University College London, also known as UCL. So UCL is founded in 1826. We've got over 44,000 students across 150 different countries. We consider ourselves as disruptive thinkers or discoveries into solution from medical treatment to houses to transportation and manufacturing process. So I'm going to talk a lot more about manufacturing process later on in this presentation. Before I do that, I want to share my journey into the materials world. Well, it actually all began when I was around 11. I had the opportunity to travel to lots of places, maybe approximately 6 long-haul flights per year, and for at least 8 to 10 years. I was wondering at the time, can we make the aero engine less noisy and also make us travel faster? And that's really how I begin to interest in look into materials. And then one day I had an opportunity to work in a department store that sells lots of different home and lifestyle furnitures. And these including wine glasses, kitchenwares, and furniture that's put at home. And I realized materials play a very important role in a society. Then I decided to take on a journey, study material science and engineering at Imperial College London, specialized in aerospace materials. And just before I graduated, I worked in the steel industry and absolutely found it fascinating. We can see how steel being made, and we work with companies to co-create products for forklift trucks, all the way to railway tracks and components associated. And then I looked up an article from Certain Partner, which is a leading architectural and engineering in UK. They were partnered up with European Space Agency to explore the opportunity of using 3D printing technology to create a moon base or lunar habitation. And ever since, I found that's really exciting. Can I get involved in this area? And I did. And for the past 10 years, I've been working in the field of 3D printing technology or additive manufacturing technologies to explore and advance these areas of research across different materials from polymers, also known as plastic, metals, glass, and ceramics. So lots of exciting materials there. One thing you may ask, so what do you actually do? Do you play a lot with metals, metal bashing, or tinkering with electronics? In fact, I both of those. In addition, I have a very a privilege to have the opportunity to use what we call X-ray imaging. Essentially, it's a light that allows us to see inside materials and also how they are being processed. So in here is a video showing how, as the materials being heated and cooling and pulling apart, and I also learned a lot about using 3D imaging technique to see the structure of particular aluminium piece as an example. But my rules continues to evolve over the years. Decided to spend a bit of time beside my daily role to speak to the public and discuss a little more and share what we do as a materials engineer. And in this particular case, on the top right corner, you see a picture of the team of three, but in fact, we have lots of people working behind the scene. We worked with a food processing industry to trying to understand how ice cream changes its structures and hence taste when you leave it out and put it back into the fridge. So that's quite an interesting project. I can pretty much summarize my goals into 4 areas shown in these colors. In green, we do a lot of thinking on a day-to-day basis. We write a lot of different types of articles. We create educational materials. We also interact a lot of people across different age, from primary school, secondary school, all the way to university. And we also work with companies to trying to solve real-life engineering problems. And we involve a bit of recruitment to trying to grow the team so we can deliver our research and benefit faster to the society. Of course, I spent a bit of time in the laboratory looking at materials under the microscope, as you can see here. A way to use digital technologies like computers, mobile devices to accelerate materials discovery and application. And we spent a bit of time looking at budgets, resources to try to manage our research portfolio. Something I'm really excited to share with you, as you can see in here, is a metal 3D printing process called laser powder bed fusion. It involves continuous spreading layers of powder and use a light beam to fuse the powder together to create parts. This, a 3D part, a physical object. Thing that we often get asked is, can we help understand how some of these imperfections, like roughness or is forming in the component? Not all of them, those, but would like to know how we can make the product and the process more consistent. So why we need to really look at, understand what's going on when the light or the lading touches the materials. Not only seeing at the surface, but really wanted to find a way to see inside this process. How do we do that? Well, I'm sure some of you are familiar with Superman X-ray vision. And we essentially use this X-ray vision inside a giant X-ray microscope. There is one out there in the UK called a diamond light source in South Asia. That's actually where our group located. And we use this technology to see inside processes instead of seeing inside a human body, as shown in the picture right above. We also needed to build some hardware and tools to simulate the printing process. So how does it work? I think I need to give you guys a scale of how the metal 3D printer looks like. You can imagine it approximately 2 to 3 times the size of this fridge you got at home. And print bed or the print area is equivalent to a size of an oven. We take a further slice of that oven tray and we create an environment. We call it the metal print simulator. It's the size of a shoebox, excluding the scanner, which steers the laser beam. And we, as the laser beam raster across a metal piece or plastic piece, we continues to image and wanted to find out what's going on. So here's an example of the final hardware looks that our team built. It has lots of other cameras looking at the process from a multiple different perspectives, so that we can get additional insight into the process. This animation show as we spread the powder, laser, the light beam interacts with the materials, and we continue to take these series of images. Some examples of the series of images under what we call bad condition. You see how these voids are forming. They could be detrimental to the 3D printed component. But we also help industry to come up with good print strategies where you see minimal amount of is forming in the metal piece. So that just gives you a feel of what sort of things we do in as a day-to-day as a materials engineer. And one thing I want to highlight why I find it really fascinating. Well, because it really enables us to create things that once were dreamed, from jewelry pots all the way to aerospace, biomedical, to even marine components. So that's really amazing. But one of the key take-home message I wanted to tell you, I didn't work alone. Over the years, I worked in a team of researchers with a diverse background, and they're all over the world. And it's an absolutely privilege to work with the brightest mind in the world to deliver these type of materials research. So just to thank those supported my work and other things to have an opportunity to speak to all of you today. So thanks for listening. If you do have any questions, feel free to email me, or you can scan the QR code and connect with me.
First of all, Alex, I'd like to ask you, what do you love about your job so far?
Oh, I love many different aspects. First of all, working with the brightest people, and also coming up with new ideas to make new manufacturing process and materials. Those are the main things that I absolutely love.
Brilliant, perfect. And you touched on during the presentation how you've worked in many different teams. How important would you say it is to work in a team within the engineering industry?
Well, what I found was when I was working through industry, even creating a product for Ford trucks, for example, it took at least 80 to 100 people. Then you
Wow.
realize you can't just do it by yourself, right? You can only play a part of that. Of course, you can lead the team, but at the end, you really need to create a really nice environment to work and drive that materials project forward. So it's absolutely crucial.
Perfect. And we have a question here from Rebecca. Rebecca's asking, what is the coolest thing you have built with this process?
The coolest thing we build within the process is, in fact, we make quite a lot of types for doing public engagement. I've got something here actually. These are the ice cream 3D printed structures. We scan the structures of ice cream at thinner than a human hair, the resolution, and then we enlarge that into something like this, and we can show the public, we can feel these structures of cream, but in
Something that's going to be quite relatable to the pupils taking part in the project this year, watching this interview. So who and what inspired you to become an engineer?
Oh wow, that's someone is you might be quite familiar. In fact, is two people. One is Trip Branson, who was another a British entrepreneur. In fact, it's the curiosity in life that drives me to become a materials engineer, because at the time I was reading a lot of articles about how we wanted to build a solar plane that can fly across the world. I thought it was a very inspiring story. But how do you make a solar, powered plane, with all these existing materials technology around? I think that's one of the reasons why I was like, wow, an explorer and engineer. That is the two best things you could come up together. Yeah.
Sorry about that. I'm hoping I'm back now. Can you hear me, Alex?
Yeah, I can hear you. Thank you.
Perfect. A little technical issue there. So next question we have, what is the most fun project that you've worked on?
One of the fun projects I've worked on is to basically, the example I showed in the presentation, how do we shrink a metal 3D printer, 3 times the size of the frame to a shoebox, like, and then to put inside the microscope? I think that was extremely challenging, but fun at the same time.
Brilliant. We have another question here from St. Mary's. How much has 3D printing improved since you joined and started working with it?
I have to say that 10 years ago, there were only a handful of companies are using 3D printing metallic parts. And nowadays, there are actually some of the aeroplanes you're flying, or automobile or cars that you're driving may have one or more 3D printed parts. So the quality might be have improved quite dramatically. In the past, 3D print technology is called prototyping, but it now is no longer just rapid prototyping. You actually could make functional engineering products.
Perfect. So I bet there's a lot more 3D printing going on than we actually realize. What would you say is the most unique product that is used as 3D printing?
I think one of the coolest things is some of the engine components for space rockets, because in the past, it may require 10 or 20 different components, and you have to somehow make them, join them together, and which is very costly, and it involves usually the development time is very long. But imagine if you can print all of those 20 things in one go in a single part. I think that is mind blowing, and it also enables us to make lighter part for space exploration. That's something I think is really cool, and it could be really beneficial for space exploration.
Perfect. We have another question here from St. Teresa's. St. Teresa's are asking, what does it feel like to use X-rays?
Using X-ray in the workplace I am based is very safe, and is really fun because you can see inside an object. So when we were training to use this machine, we then put all sorts of different objects inside this machine, such as the Kinder chocolate, for example. We want to see whether we can see like the toy in the chocolate egg. This kind of thing. It just always makes us happy and joyful when we were learning and using this type of X-ray technology.
Perfect. And St. Teresa's got another question here as well. So what software do you use in the machines?
Okay, there are 2 to 3 different types of softwares we use in the machine. One was given by the manufacturer of the control board to allow us to control the motors moving up and down, and to control the powder spring and also control this melt process. But once we capture these images, we sometimes write our own tools to extract useful information using, let's say, Python or MATLAB or those type of engineering software to get additional insight.
Brilliant. And one here from Charlotte, St. Teresa's. We have touched on already who inspired you to become an engineer, but St. Teresa would like to know, who do you look up to today?
Oh, today I look up to, well, I would say Elon Musk is another really great engineer, entrepreneur, is continue pushing the boundary of human mankind. Think about it, privatize the space industry and sending up human astronauts up there. That is truly inspiring, and the effort they put in material engineering is also amazing. Look at all the structures they created, and that is something unheard and unseen in the last 20 years in space race. So that's something someone I would say is quite inspiring.
Brilliant. And speaking of Elon Musk in the future, what's the most exciting material you think will be used in the future?
There are a few things I've got in mind. One thing is, can we actually reutilize some of the space materials and print space structures without the need of bringing materials from Earth? I think that is going to be truly inspiring and very futuristic. But on the other hand, if you're talking about something closer to the heart of what we do, I think some of the titanium materials that we are currently using for biomedical implants would also have a huge impact into the healthcare industry, because that is already happening, but we would like to see more of these to benefit more people.
Brilliant. Another question here from St. Teresa's. So St. Teresa's would like to know, what are the X-rays used for except for looking at bones?
Okay, that's so that the question is, what other things can X-ray be used for?
Yes,
so
yeah.
X-ray could allow us to look inside many different types of objects, not limited to bone or metals or plastic and anything, but some X-ray technique we can also see chemistry. So that means you can actually see what actually this particular materials or unknown piece of object is made out of. So if you are interested in archaeology, you wanted to find out how things were made, you wanted to find how what were the constituents, or what does this particular piece of object made of, and finding out what materials also help you date this object. So there are lots of application of it. Is absolutely fascinating.
Brilliant. So we have Erica at St. Teresa's asking, do you think your industry will help us in the climate change crisis?
Absolutely. One of the reasons why we are into researching or developing next generation 3D printing technology is to make components, functional components, lightweight and also stronger, so that we can reduce the fuel consumption. So one example of that is traditional machining of a component. You would need 20, and only 1 kilogram actually puts onto an aeroplane. But nowadays, we can reduce this ratio to 2 kilograms or 1.5 kilogram to 1 kilogram to put inside an aeroplane. That's an example. So you can see there is a massive cost saving, in terms of energy saving. So you don't need to make as much materials, but you could make more products or usable products out of that. So it will have an impact in the climate change and also sustainability of manufacturing.
Perfect, that's great. And we can all do our own bit to help with sustainability. So Roxanne is also asking, can you give an idea of how long it might take to print any specific item with this method? So is it a fast or fast or slow process?
Um, it could take between hours to days to print, depending on the size of the object and depending on which printing technology. So there are printing technology that could print 5 meters object in a couple days. So really, we needed to. If you're interested in like a specific technology, you could email me and I could give you a better answer because it's a general question. I hope that's okay.
No problem at all. So just having a look at the other questions now. So from Zara at St. Teresa's, what companies do you work with?
I work with several British and European companies, and one of them makes metal 3D printers, and also work with industry that makes powder materials, and also works with some industrial partners who utilize both powder and the machine to make functional parts for aerospace and automotive application.
Perfect, brilliant. And remember, everybody, we've still got a couple of minutes left. So if you'd like to ask Alex any questions, pop them in the Q&A box. Who do we have here? Some of the pupils at St. Teresa's would like to know, why did you become an engineer?
One of the reasons why I want to become an engineer because I find it materials is available everywhere. And how do we use these materials to create new things? That's really excite me. So instead of taking things apart, I wanted to know how things were made and can we come up with new way of making useful products. So that's one of the reasons why I want to become an engineer.
Brilliant. I think that's quite interesting as well because a lot of people and pupils don't realize that they're already kind of thinking like an engineer, whether that's playing with Lego or entering the competition that we run every year. So yeah, no, that's really good. We have a question here from Hugh as well from St. Teresa's. So how do the X-rays actually see through the materials?
Okay, so the X-ray interacts with the an object, a form of object. Some of the energy will be absorbed by the object, but some energy will be transmitted, which means it will get through. And then we use a piece of material. Essentially, it's like tonic water, so it converts the X-ray into visible light, and we use a camera to look into this visible light to capture an image. Essentially, that's how the X-ray image works.
Oh, wow, great. With the next question is from Rachel. This is I like this one. So you mentioned Superman's X-ray vision. If you could have a superpower, what superpower would that be?
I would definitely want to have X-ray vision. I think that is the coolest you could have. So thank you very much.
Perfect, brilliant. We've still got a couple of minutes. If anyone would like to put any more questions in the box there, remember use the Q&A section for the questions. Who do we have next? So from Neela at St. Teresa's, what advice would you give to children like us who are interested in becoming engineers?
One of the things that I think my advice would be curious. If you're interested in something, find out how it works, find out what it's made out of, and then it might shoot into a completely different path. I think that would be advice, is to be curious.
Perfect. Brilliant. Well, thank you very much, Dr. Alex. That's been a really inspirational interview there. I hope everybody's got lots of information and ready to start with their own designs for the If You're an Engineer, What Would You Do competition. Remember, we post this video on YouTube every Friday, so you can watch this back, as well as many other interviews each week. So thank you very much to everyone who's joined today, and to Dr. Alex once again, thank you so much for joining us and inspiring the pupils as they begin the If You Were an Engineer, What Would You Do competition 22-23.
Thank you all.
Thank you very much, everybody. Bye-bye.